Okay, so let's continue. Regarding the casting, then we can do the upcasting, and upcasting, when it means that we actually go up to the hierarchy, it will always work without any issues. I mean, from the variable point of view. However, we can also have the downcasting, this is what I mentioned, and this actually means that we go from the variable type point of view, we go from top to down. That's what means that we pass object with the type human to employee, the variable with the type human, the object stored under the variable type as human, to the variable type as employee, or we pass it to programmer type variable. That is possible with the restrictions, and the restrictions are that in this case the reference of employee or the reference of programmer should be stored on the reference of programmer should be stored under the class employee, under the class human. Not under the class, under the variable typed as human. So the same for employee. If I have the variable typed as employee, then I can pass the object, and then if I want to pass the object from the variable typed as human, then the reference, the actual type of the object reference should be employee, or it can also be programmer. Yeah. So then the downcasting is fine. But in some cases, downcasting may fail. For example, if I just pass the object with the type, basically if it's not one of the cases we discussed some minutes ago. Like if we have the object with the type human, then I cannot pass it to the data type employee, to the variable type as employee, and also I cannot pass it to the variable typed as programmer, and also I cannot pass it to the variable type as kid. I can only pass it to human. So, and in such cases we will have casting error. So for example, here I create the variable type as kid. So it will be kid object, and here I do the casting to kid. So, and here we will have typecasting error. So this is not the issue which will be detected by compiler. So at this point the code will be compiled, because this is not what is checked during the compilation. This will be checked during the execution, so that we will have runtime exception here. So let's let's then do it. Let's see what do we have here. Okay, that's the warning, not so important for us. And yeah, so here I have the salary as we here, sorry, not here, so type new salary, and here I have invalid cast exception. Yeah. So I have this exception, which means that the casting cannot be done. Okay. So here I get exception because person has the source, and I can write the comment. So here it will trigger exception, invalid cast exception, because we try to pass the object reference type as employee to the variable type as kid, and yeah, as I said, from this hierarchy we cannot do it, because actually kid is not subclass. Yeah, actually kid is not the subclass of employee. Yeah, we can only pass the subclass or the same class and or employee, or the object is typed as employee to this variable. So then the question is, how can we actually escape such cases? So there are different things. So first of all, we can simply, as we already know, what can we do? We can use try catch and simply catch the exception, as shown before. So we have try catch. Here I can catch this valid cast exception. Here maybe I can print that here we have the exception. So valid cast maybe just simply not like that we simply measure cost. Okay. So let's see now. Start there. So here we just simply have this try catch. One more thing, what can we do just without try catch? So that would be one option. Another option would be also similar. Also, yeah, in theory try catch, that's also the branching. But what can we also do? We can use we can actually check the data type. Data type of the object. So. Yeah, so we can check if this is instance. Why don't we have this method? It should normally be here in this range. This instance of not sure why we don't have right side display, but okay, let's check. One moment. One moment. One moment. Just from the syntax point of view. So. No. Yeah, so now everything's fine. So here we can try to get type. So yeah, everything's fine. I just was a little bit confused here. And here I can actually check type of. Type of. And here I can pass the type I'm looking for. Oh, no. Type of, that will be directly, and yeah, so here we have also is. Yeah, so more simple. So yeah, that's more simple syntax, is. So this was a little bit confusing. Yeah. So here we have is. And here I can just simply ask, is person kid? And then I can do the custom. Let's run on this, then this code will not be triggered. Oh, hold on. The statement can be the declaration of label statement. So So again, that's the query variable, and then pass it here. So just because of the operation. Okay, so then let's check now and see that we don't have error. Yeah, basically this code then will not be triggered. So here we can check. If casting can be done. And so the same is here. Same as here, before I do the casting, I can apply the check. So maybe let's first we find the variable, and then we can assign the variable. So here I can check if employee, actually here we have upcasting. So for upcasting we don't need it, because for upcasting it will work, it will always work. For the downcasting, we need it. And so here I can check it. So if an employee object is if person is employee object, or if it's employee, then we can assign it to employee object. Yeah. So that's the case how we can escape incorrect casting. Yeah. So using this statement, we can check if person is or person is not employee. So this is the statement which returns true or false. So if the object is the actual class or just any of the subclasses of this class, then this will return true. Otherwise, this returns false, and we do not proceed with this. Do you have any questions about this? So hopefully it's clear. Yeah, that would be great if I had any tasks, but yeah, this will actually be also a part of your current home task, which for this week. And there you have the inheritance. It's not really related to the casting, but the casting is quite an important thing, especially when we talk about the frameworks. We talk about different patterns used in different environments, and then we need to use the casting. Yeah, and usually the casting is needed when we transporting the objects from one place to another. There may be such cases possible. Yeah, like we simply send the object from one place to another. And in such cases, then the type which is transport may be more generic, then we need to more general. Then we need to pass it to more detailed type, and then in such cases we must do the downcasting. Also in some cases we can use, in some cases, in most of cases we use upcasting. Yeah, that actually means that, yeah, maybe again, just to try to help you to understand. So there's this picture, I can place it here. So just for you, sorry, really, so let me create this screenshot of this, and then I can attach it in chat. So, and let's just for you to understand the schema. So let's say we have the method, just any method, okay? It does not matter where it is, to which object it belongs, where it is located. It's maybe not so important. So let's say that it takes the variable, so as an importing parameter, it takes the like from our schema, it will take the object type as an importing parameter. It would take importing parameter typed as ref. Yeah. So that would be ref parameter. So is the reference. So we pass as the reference, and the type would be. So from our case, let's say the type is human. So typed as human. Yeah, so that will be the type of the importing parameter. This is the method. Yeah? Just some method. Get located somewhere, and does some stuff. Yeah, we do not really care about what's going on there, so just some kind of logic is there. Yeah. Let's make it more. Yeah, let's make it bigger. Yeah, so this method takes the parameter typed as human from our case. And then we have again one method. I don't know where it is. It doesn't matter where the method is. So just also method located somewhere and does some stuff. But in this case, well, let's maybe also name this method. Let's say this is method X. So method X. Find this both maybe. This is method X, and this method, again method somewhere, does some stuff. Method which calls method X. The method X. So, and then it passes, so we can then load the arrow and say that here we pass here we pass object, so the object would be, let's say, employee. Employee object is passed here. Then, so it passes employee object, then it is taken as human, and then this method sees it as human. Yeah. So, and then say there is another method which method is actually a method called by method X. So this is the method called by method X, and so here it actually takes it accepts employee as the parameter. So it will be, it doesn't matter if it's ref parameter, so just simply that the parameter and tagged as human, or also as an option. In this case, that's maybe not really important. Import. It's not really important. Yeah. So, and then it is called from method X. So, and here we actually have the casting, because this method takes, it means human. So here I do the upcasting. I go from more specific to more general to human type. However, this method it calls the method X. It calls this method, and this method actually takes human. So in this case here I'm doing the upcasting. Then here I'm doing downcasting. And yeah, this is what I'm trying to say, that in most cases you will see the casting is used when we transport the object from one place to another. In additional cases, so also the most popular, not the most popular, but from my experience, the most popular case when I'm using when I use the casting, yeah, that's mostly upcasting, is some kind of web frameworks. From web frameworks, the thing is that we mostly have the base classes. Then there's some kind of framework. Yeah, so there's a framework, web framework, which does some generic stuff. And then let's say that you want to enhance the behavior of this generic framework. Yeah, so let's say that you have maybe some kind of web application, website which does some things there. And so basically you want to enhance this behavior. You want to enhance this application with additional features, and then what you need to do. So, since this is the framework, it has some basic features defined, some base features. So then the question may be how you can actually then enhance all these features. So you want to keep all the base features and then to add some additional features. So in such case, you would need to, for your specific custom program, you would need to inherit this generic class, which is used as the super, which will be used then as the super class, and then you will take all the properties and simply extend the base class. And so then you will have all the features available, and in this case the custom will be used and everything will be fine. Because the generic framework will stay in place. However, we pass our extended classes to this framework and extended object, and this will work. So, do you have any questions? The casting. So basically these are the main properties of casting. It's C#. Okay, if there are no questions, then the next topic is the abstract classes. Oh yeah, one more thing. We talked about the method overriding. How to override the methods. So we already faced the method toString, which can be overridden, but the method toString originally, if we navigate here to the base, this we cannot navigate here, but the idea is that toString is the method. Yeah. So what does it mean that we override it? It means that there is already implementation created in the superclass, and what we want to do, we want to override the existing implementation with our own. And in this case, previously we also, not previously, but in our cases we also called the implementation from the superclass. So accessing the base keyword, then we can access the implementation of the superclass. However, we should also have the place from where the original method comes from, right? So the method toString comes from the class object. That's the class from where the system object class from where all the classes are inherited in C#, and basically there the method toString is defined. However, we can also define our own method, and that would be, let's say, so what can we find out here? Let me think. Okay, maybe let's simply print something that will be public void so that will be print available casting classes, such as the classes which can be casted from this, and here I can write that so only So person class can't be casted to any other class. As an option, as an example, here we can mention this. But, so this method is public, and it means that it will also be available for programmer and from kit class. But this is incorrect. I mean, the line here is incorrect. This class, because for the class kit, the information is so for kit class we need to print that it can also be casted to from the it can also be casted to the class person. So in this case, this method needs to be redefined. And how to redefine a method? So to be able to redefine a method, we need to define it as virtual. So that will be public virtual method. And then here I can override it. That will be public override print local casting class, and here I can print another information. So we'll say this object can be casted to variable typed as person. So here I actually have the same method, but the different implementation of this method, right? So that's the point. That's the point here, and then we can also proceed with other clauses. In this case, the syntax will be the same. I type public override. Instead, the class name will be the same as the class from the superclass. However, here I can define different logic. So then the program and then also employee. For employee person or employee, and then for employee. And this will be this will be non-simple person, also zero. Okay, so that's the point. That's the point. I can override virtual methods. So just make sure we don't have any syntax issues. Let's run the program. Should not have them. Everything that we find here. Yeah, so that's about method overriding. We can override all the virtual methods. So this method is defined as virtual and it can be overridden in the subclasses. So if the method is defined as virtual, and it can be overridden. Actually, then we can override it in the subclasses. So in all the subclasses. Yeah. So that's the point for virtual methods. Okay, do we have any questions? So basically means that the implementation can be different. We can also skip overriding these methods, but in this case, that the implementation from the superclass will be called. So then I can say if the method, if we dot override method, the implementer, method in the subclass then the method from the base class, the implementation. The implementation of the method from the base class will be called none. So that's the point. And if the implementation of the base class is not overridden, then the implementation of the superclass of the base class will be called, and so on. Yeah? So just on the top to the hierarchy. Okay. So that's the point. Do you have any questions? Okay, then if not, we can continue. Yeah, so just in case you have any questions, please let me know. And yeah, so just doing the question, do you have any questions about the assignment about the object-oriented programming? So scheduled for this week. Do you have any questions from there? So that there's just open it. So there you have how to add objects to an array list. We have this case here. So here we have array list will define it, and to add objects to array list. So here is the example. You can check it. I'm commenting some code because I'm trying different options in different programs. So just for you to be able to check the code, I'm keeping this code. But I mean, on the practical example, when you submit your final code, then please don't keep this comment code, because since in case it's not needed. The question is, so with the methods is the only way? Yes, that's basically what the array lists, what the collections are about. The collections are the objects. So basically, to proceed with the objects, we need to call the methods. Yeah. But yeah, so you can do it using the method. And that's fine for questions. This is how we usually do it. Okay. So that is for the array lists. Yeah, what else? There is the task 2, task 3. So here you need to call the officer class. That's fine. I hope that's not the issue. Oh, no, sorry, task 3 as well. So here we have to copy both classes, and yeah, so then here you have the inheritance. Here you have the inheritance, and so in this case we have class person, which is something similar to what we created yesterday and today. Yeah, and here we have two subclasses. We have the subclass lawyer and subclass officer, and they both should extend the class employee. Class person, yeah. Just a second, I think. The class employee first. Class person. So just the class person. Yeah, lawyer and officer, they both extend class person. So that's the part. So I hope for this, after yesterday's and today's session, that won't be the problem. So, and here we actually need to use the class officer as the type for the officer, and here you can actually use the array, you can use the array list, you can use linked list, that's up to you. Yeah? That's not so important what kind of collection you use here. Even I would recommend to use maybe array list. That would be more efficient here. So can I see the questions? Yeah, just any questions about the home task, please let me know. So here we have the inheritance, which yeah, that's why I wanted to discuss it yesterday, and since this is the major part of the object-oriented programming. So the question translates, so when we create an instance of the class, okay, say where, okay, and that inherits after a person, yeah, that inherits the person class, yeah. How do we write a code for constructors? So for constructors, since we have non-argument constructor, for such cases we don't need to pass anything. For argument constructor, yeah, that's actually a good point. That's a good point. How to write the constructors here. So it's not actually defined. So in theory, you would need to just simply write the constructors as they are. So if you, in such case, if we have non-argument constructor, then in this case, it is not mandatory it is not mandatory to call the constructor from the superclass manually. Yeah, since non-argument constructors will be called automatically, except the cases when we call non-argument constructors from the subclass. But in this case, in the task, it is actually not defined. Yeah, so in theory, you can simply write non-argument constructors. However, since when we create the warriors, we also need the warriors and the officers. We should provide the name and the surname as well, or in the argumented constructors. So in this case, you will need to then proceed in the way we proceeded here. So that means that for non-argument constructors, there's nothing to do for non-argument constructors. So that will be this way. We cannot do it in this case right now because we don't have. So I can also write a comment. But yeah, in your case, non-argument constructors will look this way, and then the code will be compiled in your case because you have non-parameterized constructor in the superclass. So in this case, that is not possible. Not possible to leave the constructor without calling the constructor of the base class because it has no non-parameterized constructor. However, if we have non-parameterized constructor in the superclass, then we can keep this code. But yeah, so if we go back to the home task, then so for here you would need to. So for argument constructors, you would need to then write them this way. So by calling the argument of constructors from the superclass. So then that would be the same way. So in this case, that would be you write in your case that would be the constructor of where class, and then you have where ID, help and crimes solved. So these parameters should be passed. Plus, you should also pass the parameters for name and surname. And so instead of salary programming language, there you will have where and help crimes solved. And then we'll need to call base class like the same way as it is here, and pass name and surname. And so for officer, you'll need to pass officer ID to the constructor, and then to call the parameterized constructor of the superclass, where you pass again name, surname. Right. So that is how you need to pass. Okay. So again, then you have two constructors. Again, you have constructor which is, not two constructors, but you have the constructor from the base class. So these are defined in the base class. These are defined in the base class. This is defined in base class. Okay, so for employee, the base class is person class. So then this constructor is called. And then for employee, we call firstly this constructor is called, which comes from the base class, and then this constructor is called, which has this logic. So the same should be done also in the on task for parameterized constructor. For unparameterized, non-parameterized constructor, we do not call the constructor from the superclass. Okay, is it more clear? This, so we have two constructors. We have constructor from the superclass. But yeah, so for wire, you still need to then pass name and surname as well, like we did here for the programmer. Yeah, so here I still pass name and surname for programmer constructor. But then from here, these parameters will go here to this constructor called, and then this will call the constructor from the base class. So is it more clear or maybe something? Okay, so that should be the same for parameters. Okay. So and here you basically have the inheritance. Then you also have the class composition, but in this case that's simple. You just simply use the data type, which is the officer class, in the collection of another class. And so here you have all the same details. And so just if something is not clear, please let me know. For the fourth assignment, so here you have the class person. Again, that's the inheritance is the same. And so there's nothing special. Then copy of so that's just to do manually, to be done manually. So yeah, all years district. So then this is this way, so then create, and it's fine. And it so there's basically nothing special. So here you also have calculate average level in district. So here you will need to then proceed. So here's the point that average level in district can only be calculated for the officers, and this is where we use the casting. So basically it means that this will be the method which will take both all the persons. Yeah, it will take all the persons. However, the calculation should be done for the officers only. So basically, it will go through all the persons. However, the method calculate level will only be called for officers. So for warrior, in case the person is warrior, we do not calculate level. Yeah. So that's the point. So basically, this here we have this calculate average level. Calculate average level in district. So here we actually took all the officers. However, in your case, you will take the persons, not the. So the persons may also be the officers. So in that case, you will receive person, and then you will need to check. So if like we'll have the person, yes, so we will go through. I will write the pseudocode there, so that this will look like this. So I will write simple common code. So then you will have for each person, that would be person, and then you will have not officers in district, but persons in district. So we have district, so we have persons in district. So then this would be persons in district. Persons in district. Sorry, moment. Yeah, persons in district. And then you will first we need to check. So then if this has the comment code. So then this will have a check if person, if not, if not person is the officer, then you simply go to the next this will be continued, then go to the next iteration, we continue. That will be for your case. Skip current iteration. Yeah, so otherwise we know that the person is officer, so then we can cast person to the officer. So here we'll then define the object, the object variable officer, and then I can do the casting. So then I will do the outcasting there, and there I will pass the person to the officer. The person object, the object stored on the person to the variable type as officer. And so then I don't need to check if officer is no in that case, and then from here I can then check if the officer is, well, then I can calculate arbitrarily. And so I will copy paste this code, and yeah, of course at the end you will need to then yeah, however, that's for this case. In addition, you would also need to modify the method which gets the number of the officer in district. Yeah, so for that case, you would also need to. But however, so do we have this method here? Okay, we don't have this method. So in this case, you can proceed with the counter. So that would be the counter officers in district. We start with 0, and then we also increment this counter. As a counter, I'm just writing the pseudocode for you so you can use it in your home task. And then at the end I will need to return it, and then I can return the sum divided by this counter. So then this code, so that would look this way. So that's the prototype, I guess. There's no syntax issue, but just for you to use it in your home task to calculate the officers in this. So here you need to use the downcasting. Since we need to take the officers from all the persons. So just for your home task, in case you want, you can also do it in groups. Yeah, so I also don't mind if you do it together in groups. So just if you see that that's complicated, then you can join with other teammates and collaborate. That's absolutely fine for me. So just in case you want, you can collaborate. Okay, so do you have any questions about it? And despite this, I don't see if there is anything more specific there. So do you have any questions? Okay. So then if not, so I guess you have everything for your home task. So I think that maybe we can finish earlier today since you have this home task, and it most likely will take some time for you. So just then for you to be able to finish this home task. So maybe I can give you more time. Yeah. So it's for the session time, and then you can proceed with the home task. And just in case you have any questions, then I'm free for them. You can ask and let me know if something is unclear for you. But I want to give you maybe more time, and also you can proceed with the home task, and that's why we can finish a little bit earlier today, so you can proceed. Okay, so is it fine for you? Or you maybe need more things to want more topics to discuss. So I'm free for them. So Anastasia stepping. Yeah, just any questions, please ask. Yeah, that's the question. No, that's what we used today. That's about the checking if the casting can be done. Yeah. So that is this is about. We use the casting for this. So there are different alternatives, but from my point of view, S is the best option to use here. So that's to check if the casting is possible. Since we do the down casting, we need to use this. You have to check if the casting is possible. Okay, the question from Winner: find out the total number of primes in which solving the Weyer's law. Well, is it possible to calculate this making a method in Weyer clause? Yeah, let me check the structure. What do we have here? So the Weyer clause. So total Weyer in which the Weyer were involved. Moments. Where's the linkage? Yeah, there are 3 different objects. And so where's the linkage between the Weyers and my sorry. So hold on. From total number of primes in which solving the Weyers were involved. So that was this one, right? So then we have Weyer ID. So that means from one listed. And the total number of primes in which solving the Weyer's law. Yeah, so in this case the Weyer's law. Oh, hold on, no, there is one Weyer. I'm just confused. Which solving the Weyer's law. Yeah, that's how primes solve. Oh no, hold on. That's just simply you need to do from your main method. So in main method you would need to then go through all the wires and then just simply count just simply sum all the crimes for each wire. Yeah, so you need to go, that should be done in main class. In theory you can also write it in whatever place you want, that's up to you. You can just simply pass, for example, you can pass them all into the, you have array list. Okay, you can array list, so in theory this can also be done in the wire class. In the wire class you can create static method. Yeah, then this should be static. Yeah, you can have a static method which will accept array list of wires, then you can implement the logic there. That should be fine as well. Yeah. Since all the wires are stored in an array list, you can simply pass this array list in any class you want. In the wire class that will be fine as well, yeah, but then this should be static method. This should be static method since here we have the array list which is simply not related one-to-one to any object. It stores multiple objects, so that's why we cannot really define the instance method, because we have different objects. So instance method is something what belongs to one object, but since we have the array list of many wires, since that means we have multiple objects, so in this case that should be static method. Yeah, but that's also an option. Yeah, so this keyword will not work because the wires are located. Yeah, and yeah, one more thing, just about this keyword. Please remember that keyword this refers to the current object, so it means it can only be used from the objects. But remember, so if you write main method is static method. The static method, so it is called without the involvement of the object. And in this case, but inside the static method we cannot use this, because again this refers to the object, but in static method we have no object. The static method is called from the class, not from the object. That's why this does not exist just simply. Yeah, this is the instance of the object we are currently in, so it means that it can only be called from the instance methods. Yeah. So that's the thing. So we use the variable, like in this case we use the variable employee if we are inside any of the method of employee, like here, then this means the actual object we have here. Yeah, so here we created the object, so we have the reference of this object stored under this employee variable. Then if we call any method from this any instance method from this employee variable, then the reference stored here is actually the same as this. Yeah, so in this case employee stores the same reference, this employee variable stores the same reference as this stores. Okay. So that's the point, and that's why it is not possible to be done from the static method. The static methods are called without the creation of the object. So in this case we don't have any object here, and that's why this is not possible. Yeah, and also for the static methods, so just if you created from wire class, and then you in wire class, then there you define it as the static method, then you also won't have this, but this is not needed in that case, because you will have the array list of wires which then can be passed, and then you use the array list of wires. Then you don't need to use anything else there. Yeah? So you have array list of wires. So there you store all the wires as the objects. Then you need to go through all these objects, and for each object you need to get the level, right? Oh no, not the level, but get this help and crime solved value. And then just simply need to go through all the objects and sum all these values. Okay. In fact, there is also the possibility to use lambda expressions there, but that's maybe more complicated syntax we will not use now, so just like now we can create the method. and do everything there. Okay, do you have any more questions? Okay, then if there is no questions, so I'm free for any questions, so just in case you have, please let me know, but then I can give you, as I said, more time for this assignment so you can complete it, and then we will go through it then on Monday next week. Okay. Then yes, so please then finish these two assignments. I mean these two tasks, assignment 3 and assignment 4. Again, as I said, if you want, you can also collaborate in groups. That's fine. And yeah, so you can create a common repository, then share it with me. That's also fine. That's also fine. And yeah, then once you are done, please let me know that you are done. I will then check it. So let me then push the changes. Today is that's already Thursday. So okay, so now the code is pushed, so you can check the details from there. Okay, then if you have no questions now, then you can ask them later. Yeah. And I will reach you once I'm available. Okay, but then for this week, then that's it. So thank you very much for your attention. Have a nice evening today. Have a nice weekend ahead. And then waiting for your assignments. And then see you on Monday. Okay, thank you. Have a nice weekend.